Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the questions from the class 11th NCERT part 2, that means from mechanical properties of solids to the waves. But unfortunately there is no questions from mechanical properties of solids this year, NEET 2025. So we are going to start with the mechanical properties of fluids. Maybe this question is looking very big, but this is the only data we have to just apply here: units and measurement, dimensional analysis. Okay, so let's start here. The first question: a balloon is made up of a material of surface tension S, and its inflation outlet from where gas is filled in it has a small area A. Now, it is filled with a gas of density rho and takes a spherical shape of radius r. When the gas is allowed to flow freely out of it, its radius small r changes from capital R to 0 in time t. If the speed of gas coming out of the balloon depends on r, as r to the power a, and this is given here, and here they are asking here which options are correct here. So by reading the question we have to just identify that S is the surface tension, you can see, A is the area, rho is the density, and r is the radius. And what is t? T is the time. Okay, this is only we need here. Okay, so this thing we are just going to write here, that I have written. Okay, so what is t here, students? The t is the time, so I can write here m0 l0 t power 1. Is it directly proportional? Means no problem, we are just writing here the dimensional analysis. Okay, what is surface tension? Surface tension is given by force by length. Force means mlt minus 2 by L. So L will cancel, it will become here mt minus 2 alpha. Okay, what is A? A is the area, that means L square beta. What is rho? Rho is the density, that means ml minus 3 gamma. And r is the water, radius, that means L, and here it will come here delta. Is it? Now we have to just simplify this here. Okay, so let's take here, I can write here C m0, is it, and we can write here C l0, and we can write here t power 1 is equal to what will become here. Kindly say the students here m power, how much is this? You can see m power alpha, and here m power gamma. Okay, so I can write here by the exponent method alpha plus gamma. Similarly, length, how much here? This side no length, but here how much here? 2 beta here minus 3 gamma, and here plus delta. Okay, and if I write here the t, so t what will become here? Only here t is this minus 2 into alpha. Okay, minus 2 alpha. Now after that here both the sides will compare the power. Okay, compare the powers here. Okay, so first you can write here m power 0 and m power this one, so I can write here alpha plus gamma equal to 0. Is it? Next one, if I compare the coefficients of t, here t power 1 and here t power minus 2 alpha, so minus 2 alpha is equal to 1. So alpha will come here, what here? Kindly see very well here, alpha will come here minus 1 by 2. Is it? And this thing if I will use here, that means what will come here? You can see very well here, gamma equal to minus alpha minus minus plus, so it will become here plus 1 by 2. Is it? And one more equation you can write here, you can see here, this is 2 beta minus 3 gamma plus delta coefficient of L, and here how much here? 0. But this equation we cannot simplify, this value we know now, we have to just eliminate the answers in options, and then we have to get here. Remember that here alpha is minus half and gamma is plus half. So where it is coming here, alpha is minus half, alpha minus half is coming here, alpha is minus half coming here, and gamma is the plus half. So you can see very well the gamma is plus half here only. Okay, that means correct option is here option C. A, B and delta value, when you will put in a third equation, that equation will be also satisfied. Okay, not a big deal. Next, students, mechanical properties of fluids question, looking somewhat big, very tough question for the mechanical properties of fluids, but okay, we will learn here. So see here, the question is, consider a water tank shown in the figure. Okay, it has one wall at x equal to 1 and can be taken to be very wide, in a z direction. I am writing this down. When filled with a liquid of surface tension S and density rho, the liquid surface makes angle theta naught here with the x-axis at x equal to L. If yx is the height of the surface, then the equation for yx is how much here? Okay, and here we are using the mathematical approximation. When the sine theta is very small, you know very well. So sine theta, tan theta, and theta we have to write here dy by dx. And what is g? G is the acceleration due to gravity. Okay, and these four options are there. Okay, so See here. Here I have drawn here, this kind of diagram is given here now, and here they have given that here this angle they have given here the theta naught. Okay, so here we have to apply here the property of the surface tension now. So what will happen that here, what is the surface tension property? According to surface tension property, the free surface will behave as a elastic membrane here. Okay, and remember that here, if in case this is the one surface now, and let's take this is having length L. So because of this property, what will happen that here, on this imaginary line it will exert force F. Is it? Try to behave as a elastic surface now and occupies minimum surface area. So from here, for one free surface, surface tension is always given by S equal to F by L. Okay, this basic is needed here, S equal to F by L. Okay, now we will use here. Here what is happening that here, this is the everywhere liquid is there, but I have taken only this part of the liquid now. And let's take here, this is at a distance of x. This is at a distance of how much here? X. Okay, and this length, very small length dx, I have drawn somewhat bigger so that we can just see from our eyes. You can also see here. Okay, so this is the dx here, and let's take here this one here. This is the y, is it? And this is the y. So if I draw here this line here now, so this will become here y plus dy. Remember that here to here is y, and here to here is dy here. I can even write here, no problem here. Na? Again I am telling you, see, this is the y and this very small dy. So total how much? Y plus dy. But now what will happen that here, this is the free surface. Okay, this is the free surface. So what will happen that here, free surface, what will happen that here, minimum surface area, and it will behave as an elastic membrane. So what will happen that here, these molecules, they will exert force in this direction somewhat, is it? This is F. Okay, and this kind of molecules, they will also exert force in this direction, F. Okay, you can see both the sides F and F now. And now let's take here angle. Let's take here the students here, see, this angle, based upon this, we have to see because of this only, see, this is theta naught. So here also I have taken in the same fashion theta. Okay, and after that, you know very well here, this is also very dx length is this, na? The curvature is changing. So here also I will take here this, I will take here theta plus d theta. Here theta, and here how much I have taken? Theta plus d theta. Okay, now after that here, what will happen? Let's see here. This side one force will be this, na? By the rectangular component, what will be this? F sine theta, is it? And here also you can see this side F cos theta, and here upward. What is the upward force will be there? F sine theta plus d theta. Okay, F sine theta plus d theta. This side F cos theta, this side F cos theta plus d theta. That is no use, but okay, this is there. Now what will happen that here, according to the surface tension, liquid lies in the capillary. That basic we have to use, and you know very well here, this upward net force will be balanced by the weight of the liquid in this column. This much column I have taken here. Okay, so weight means I can write here, kindly see very well here, dm into g. Okay, now students, what will happen that here, if I write here, let's take here, this is the mass is there, weight will act in this direction, dm into g. So because of net upward force only, what will happen that here, this liquid is rising. No, liquid is rising here, is it? So what is happening that here, see the students here, this net force is given by here upward force, how much here, F sine theta plus d theta minus F sine theta, density, what we call mass, dm. Dm means mass, means density into volume, is it? This dm is becoming here density into volume into g, is it? We have to simplify this. As you know, angle theta is very, very small, so sine theta will become approximately how much here? Theta. Similarly, sine theta plus d theta will become here theta plus d theta only, minus here also f theta rho. What is the dv volume? dv volume, this volume. So remember that here, volume is, you know, area into length, is it? So this is dx, and let's take in this direction we have z, no? In this direction z. So this surface area, how much here? I can write here z into dx. This is the surface area, no? And height. How much height is this? This height is y here. So I can write here z dx into y. Even if you write here like this here, see here please. This is the dx, and along z direction outside I have taken here z, is okay. So this is the surface area here. Remember that here volume I am writing here area into length here. Okay, this is dv equal to a into l. So area how much is coming here? Z into dx, no? This here surface area will form here, and into y, this height y is there now, into this g is there, is it? So now students, again, you know that here force means S into L, is it? But you know very well here force here. This surface is there like this in Z direction. So everywhere what will be there? F, 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 F. But this length how much here? This length is the Z, okay? So this force is given here S into Z. Again I'm telling you here, this is the Z and everywhere force will act here, okay? So we can write here F means S into Z. And here, what we can write here? Theta plus d theta minus theta, is it? And here rho z dx into y into g, is it? So now what will happen that here, see the students here, this theta and this theta cancel, and from this z is also cancelled, okay? And now we can write here, kindly see very well here, is it? So here you can see a d theta, so we can write here, see, this d theta and this dx I have taken this side, so d theta by dx is equal to rho g by s, is it? And what will come here? This y will also come here. This s I will send this side here, is it? Now after that, see here students, this d by dx, theta value how much here? Kindly see back side here. This theta value I can write here dy by dx here, is it? So this will become here dy by dx is equal to rho g by s into y here, okay? So it will become a double differentiation, d2y by dx square is equal to rho g by s into y, is it? So this is going to be the our equation, d2y by dx square equal to rho g by s into y. So you can see very well here students, the correct option is here option B. Little bit complex question, okay? This kind of question generally don't used to come in exam, but okay, anyhow, see in how much beautiful way we have solved it by using the basic of the liquid rise in a capillary, okay? Next question belongs to the thermal properties of matter here, okay? So let's go through the question. The question is, three identical heat conducting rods are connected in series as shown in figure. The rods on the sides have thermal conductivity 2K, you can see 2K, 2K, while that in the middle has thermal conductivity K. Now, the left end of the combination is maintained at temperature 3T, you can see here, and the right end at capital T, you can see. The rods are thermally insulated from outside. Thermally insulated from outside means whatever heat will enter from here, whatever heat current will enter from left side, same heat current will go that side also, okay? In steady state, the temperature at the left junction is T1 and that at the right junction is T2, then the ratio T1 by T2 how much here? Steady state means very simple, whatever heat current is going to enter, same heat current will go outside, there is the no loss of heat from the surface, okay? So remember that here as they are connected in a series connection. So remember that here, let's take here heat is H1, now let's take here heat is H2 and here heat is H3, okay? So first I will write here one formula, heat current formula you know very well, H equal to Ka T1 minus T2 by L, is it? This is the heat current formula here. K is the thermal conductivity, A is the area of cross section, T1 minus T2 is the temperature difference and L is the length, okay? So this basics only we are going to use here. First here the heat current, H1 equal to H2 equal to H3, like they are connected in a series. What is H? Heat current, okay? So you know very well here, they are the identical rods, is it? So can you see here? It will become here, see, 2K into A, this is the here area of cross section, okay? This is the area of cross section. So 2K into A, temperature difference how much you see? 3T minus T1. See here, 3T minus T1 by L is equal to H2 how much here in the same way? K A T1 minus T2 by L, okay? I am writing here because diagram is available here, so only I am writing like this here. Now next one H3 how much here? You can see again here 2K into A, okay? And here T2 minus T. See temperature difference T2 minus T by L, is it? So students, this is the situation. We can cancel out the whatever things can be cancelled. You can see very well here. AL and AL is cancelled here, okay? This thing is needed because the diagrams are this side here. So now we can write here, you can see this side here. So I can write here, see, 2K 3T minus T1 is equal to even K T1 minus T2, and here also 2K I can write here T2 minus T here, okay? Even you can see also because I remember the diagram here, okay? 2K K 2k, 3t minus t1, t1 minus t2 and t2 minus t. Okay, so this thing we have got here. Now again what will happen that here, this k and this k is also cancelled here. Now, so what we can write here, see here students, just multiply 2 inside, so 6t minus 2t1 is equal to, here kindly see the students here, t1 minus t2, and here what will become here, kindly see the students here, 2t2 minus 2t. Is it? So this is our equation. Now after that, one by one we'll go ahead here, see first one. First one, what I am going to do here, I am going to make here this equation, 6t minus 2t1 is equal to t1 minus t2. Is it? So if you will simplify this, it will come here 3t1, because I sent this side here, 3t1 minus t2 is equal to 6t. Is it? Now second thing, I am going to equate this one, 6t minus 2t1 is equal to this side here, 2t2 minus 2t. Is it? So again when I will simplify this, what this will become here, kindly see very well here. Okay, 2t2 minus 2t. Okay, so see this one, this will become here, see 2t1, I will send this side here, 2t1 plus 2t is equal to minus 2t this side here, that means 8t. Is it? Now divide both the sides by 2, so t1 plus t2, because 6t plus 2t 8t, na, divide by 2, that means 4t here. Okay, so this is one equation. Is it? And this is also one equation, t1 plus t2 equal to 4t. Is it, students? Just kindly check out one time, mistake should not be there, otherwise answer will not come here. Okay, so now we have got here these equations. We are going to simplify this equation. So see here, this equation is 3t1 minus t2 is equal to 6t. This is one equation, and this is here, t1 plus t2 is equal to 4t. Is it? Let's add both the equations. So when we will add the equations, what will happen that here, this will cancel out, no? So 3t1 plus t1, 4t1 is equal to 6 plus 4, it will become here 10t. Is it? So what is that t1? T1 will become here 10t by 4, or we can write here 5t by 2. Is it? This thing we have got here. Again, now t1 we got. Now t2 how much here? Anywhere we can get here. See, again I can write here t2 equal to, from here, 4t minus t1. What is this? 4t minus t1. So here we can write here 4t minus 5t by 2. So when you will take the LCM, 4 into 2, 8t minus 5t, that means 3t by 2. t2 how much is coming here? 3t by 2. Okay. So after the students, when you will take here the ratio, just take here the ratio, this t1 by t2 will become here, kindly see here, 5t by 2 into here 2 by 3t. 2 by 3t. So 2 cancel. T cancel, it is coming here what? It is coming here 5 by 3. Okay, so just some calculation part is there. So 5 by 3, where is the answer? Can you see the students here? 5 by 3, 5 by 3, the correct option is here. Option C is the answer. Is it? Great, great, great. See how much beautifully we are solving that. Now students, let's see, this question is this. No, the question is from kinetic theory of gases. Okay, so let's go to the question. The question is, an oxygen cylinder of volume 30 liter has 18.20 moles of oxygen. Now, after some time, oxygen is withdrawn from the cylinder. Its gauge pressure drops to 11 atmospheric pressure at temperature 27 degrees Celsius. The mass of the oxygen withdrawn from the cylinder is nearly equal to how much here? And here some date and all is given that we have to use it here. Okay, students. So we will do here one by one. So first, what is given here? See, volume how much is given here? The volume of the cylinder is given here, the 30 liter here. Okay, so let's note down the data here. Volume is given here. How much here, students here? 30 liter. You know very well here, 1 liter means 10 to the power minus 3 meter cube. Okay, so 10 into 10 power minus 3 meter cube. So it will become here 0.03 meter cube. Now, because we have to solve everything in a SI. Okay, volume is completed. Initial moles, how much is given here? You can see very well here, 18.20 moles here. Initial moles. Ni is given here, how much here? 18.20 moles. Okay. Now, after that, what is given here? You can see here. Next one, gauge pressure. 11 atmospheric pressure, gauge pressure. You know very well here, gauge pressure means absolute pressure minus atmospheric pressure is called here the gauge pressure. It is given here 11 atm. Okay. TA how much here? 1 atm. So 11 atm plus 1 atm, it will become here the 12 atm. Is it? Gauge pressure is the 11, P minus PA is the 11. So P will become here 12 atm. Now again convert into the SI. 1 atm value, how much is given here? You can see 1.01 into 10 to the power minus 5 Newton per meter square. Okay, so all this data is given here. If we talk about the temperature, how much is given here? 27 degrees Celsius. What is the SI unit of the temperature? Kelvin. So we have to add here 273 and we'll get here the 300 Kelvin. Now, all this data we note down here. So initial number of moles we know. If we can find out the final number of moles, then we can easily find out how much oxygen is withdrawn here. Okay. So students, kindly see here. You know the ideal gas equation. What is the ideal gas equation? See here. PV equal to nRT. We are going to solve for the final situation. PF, VF, and here NF, and here TF. Is it? So this final number of moles will come here what? Can you see here? PF, VF by, we can write here R into TF. Is it? Very basic. PF how much here? Students, you know very well, 12 atm, that means 12 into 1.01 into 10 to the power 5. Okay, VF what we have got here? See, VF, this the, now initial and final volume same anyhow, is it? Because the volume of the gas is the volume of the space. Okay, so initial and final volume both are what is same. This is initial also, this is final also. Okay, so 0.03 here. Okay, I will write here 0.03. Okay, R value how much is given here? Kindly see here R value. We have to use this value 100 by 12. Okay, so we'll use here 100 by 12 here, 100 by 12. And temperature how much here? It is 300 Kelvin. Is it, students? So just little bit this data is given. You have to just simplify this. Kelvin no need to write here even. Okay, because we are not writing the unit for others also. No? So when you will simplify this, students here, when you will simplify this, it will come here just 14.55. Now I have just done the calculation also one time. 14.55 mole here. Okay, and this is the final number of moles. And you can see very well, this final number of moles are less than the initial number of moles. Okay, so we can write here moles of oxygen withdrawn. Moles of oxygen withdrawn. How much here? We can write here Ni minus Nf. Ni how much is there? You know very well here. Initial number of moles 18.20. Is it? So I will write here, see, 18.20 minus 14.55. Is it? This is this. So students, when you will simplify this here, 18.20 minus 14.55, it is coming here 3.65 mole. Is it? This number of moles are withdrawn. So if I write here the mass of oxygen withdrawn here, what is this here, students? Mass of the oxygen withdrawn here. You know very well here, N equal to mass by molecular weight. Is it? Mass by molecular weight. Is it? So in the same way, we can write here this Ni minus Nf, this number of moles withdrawn into mass of the oxygen here. Is it? So Ni by Nf how much here? 3.6F, and here it is given here the 32. Okay, students. So when you will simplify this here, so it is given here the 32 here, is it? So when you will simplify this, it will come here, see, 0.116. What is coming here, students? 0.116 kilogram. Kindly see very well, 32 into 3.6, 3 9 something, and when you will simplify this, 0.116 here. Okay, students, the correct option is here. Option C is the answer here. Is it? See, in how much beautiful way we are solving this. Now, great. Now, students, next one, see this one here. Is it? Again, kinetic theory of gases question. See the question. A container has two chambers of volume V1 equal to 2 liter and V2 equal to 3 liter, separated by a partition made of a thermal insulator. That means the heat cannot transfer from one chamber to another chamber. Now, the chamber contains N1 equal to 5 and N2 equal to 4 moles of gas at pressure P1 atm and P2 equal to 2 atm respectively. When the partition is removed, the mixture attains an equilibrium pressure of how much here? Okay, students. So just let me draw here. See here. I have taken here like this here. Okay, so that we can even think actually what is happening right here. No? So here I have taken here. This is the one wall is there here. Okay, so this is the chamber 1. This is the chamber 2. Okay, so now first one we are going to solve for the chamber 1 here. Okay, so for the chamber 1, if I write here the temperature, you know PV equal to nRT. What we know here, students? PV equal to nRT. So temperature of the chamber 1 is given here. See here, P1 V1 by N1 into R. Is it? Because PV equal to nRT, na? Temperature of this chamber 1 here. Okay, this T1 here. So what will come here, students? Just see, noting down the data is very, very important. P1 is how much is given here? 1 atm. Okay. V1 is how much is given here? 2 liters. So 2 into 1 means 2. Okay. N1 is how much is given here? Kindly see very well. N1 is given 5. Okay. So 2 by 5 R. Unit P1 V1. P in a ATM. Okay. Unit also very important. V1 in a liter. Okay. V1 in a liter. And N1 what is given? N1 in a mole. So we can write here mole inverse here. Is it? This unit is also very important. Okay. So it's the temperature here. Now next one is here. This is the second gas is there now. So here what will happen here students here? This T2 is given here in the same way. P2 V2 by N1 into R here. Okay. Temperature in the second chamber here now. Because thermally insulated, first we'll find out the temperature. Okay. So here what will happen here? P2 V2. P2 how much is given here? See. P2 is the 2, V2 is the 3, so 2 into 3 means 6, okay, 2 into 3 means 6. N2 how much is given here? N2 is given here 4, so 6 by 4R, or we can write here cancel by the 2, so 6, so here P2 V2, P2 is the 2 and V2 is 2 and V2 is 3, 3 into 2 6 and N2 how much is given here? 4. So how much is coming here students here? 2 3 is 6, 2 2 is 4, so 3 by 2 are here. Okay, 3 by 2 are here also here students here. Atom, liter, mole inverse here. Okay, can you see very well here students? No? Atom, liter, mole inverse here. Check out here very well. P1 V1 means 2 into 1. P2 V2 means 2 into 3 and N2 is given here 4 here. Now N2 is given here 4, this is given here 5. Is it? This thing we have got here. Now students what will happen here? When we will remove this? No? When this chamber will be removed. Is it? So the gas will flow from thermal equilibrium will be there. So high temperature to low temperature here. Okay. So in this situation, if we write here the final temperature. Okay. So here the students here, this final temperature is given here. Remember that here N1 T1 plus N2 T2 by N1 plus N2. Okay. This formula I have to remember that here. Okay. So now students here N1 T1. N1 T1 what is coming that here students here? N1 T1. So N1 T1, N1 means what is given here? N1 is given here 5. So 5 into 2 by 5 are here. What is coming here? See, 5 into 2 by 5 are here. Plus N2. N2 how much is given here? Kindly see very well here. N2 is how much here? 4. 4 into 3 by 2 are here. So here 4 into 3 by 2 are here. N1 plus N2, that means 5 plus 4. How much is coming here? 9. Okay students, so now let's simplify this here. See, anyhow, this 5 is cancelled and you can write here, see, this 2 2 is 4. Okay, so what will become here? Kindly see the students here. This will become here 2 by R plus it will become here 6 by R by 9. Is it? So it will become here 2 by R plus 6 by R, 8 by R by 9. So it will become here 8R by 9 here. Is it? 8R by 9. That is the final temperature here. Is it? Final temperature here. Okay. Units. Respective units we can use here. After that students here in the question, what they are asking here? In the question you can see very well what is the equilibrium pressure here. So final temperature we know very well here. So you know PV equal to nRT. Again we'll use here. P equal to nRT by V here. Okay. Final volume, final temperature, and this one here. Final number of moles here. So total number of moles how much here? Total number of moles here is 4 plus 5, 9. Okay. Overall 9. Okay. And R. After that, what is coming here? See the students here, 8R by 9 here. And total volume, how much here? Total volume, kindly see the students here. Total volume, 3 plus 2, how much here? 5 here, 5. Okay. So after that, what will happen here, the students? Just simplify this here. Here mistake is this 8 by 9R. 9R will shift downward. No, see here, this 9R here. This R and this R should cancel out here, okay? And this 9 and this 9 also should cancel out. So it will become here 8 by 5, okay? So 8 by 5 means it will come here 1.6 atm, okay? So first we find out the temperature of the first chamber, temperature of the second chamber, final temperature when the wall is removed, and then we have got here this final pressure here, final pressure. And how much is coming here? 1.6 atm. Is it? Great. Now students, let's see the next question is here. Is it? So see, the question is here. The question is from the thermodynamics. See the question. The question is, two gases A and B are filled at the same pressure in separate cylinders with movable pistons of radius RA and RB respectively. On supplying an equal amount of heat to both the systems reversibly under the constant pressure. Pressure is also constant here. The pistons of gas A and B are displaced by 16 centimeter and 9 centimeter respectively if the change in their internal energy is same. Internal energy change is also same here. Then the ratio RA by RB is equal to how much here? Okay. So here number of data is given here. First we will note down here one by one here. First thing you can see here, at the same pressure, now filled at the same pressure. So remember that here students here the pressure is constant. Pressure constant. Next one you can see here, students, see here. Equal amount of heat. That means what is given here? This you can write here. Delta Q is also constant. Heat is also constant. Heat is also constant is given here. After that, same pressure and here also constant pressure. No problem is there. Okay. And after that you can see here, internal energy is also same. That means delta U is also constant. Delta U is also constant. Is it? And what is given here? You can see very well. These pistons of gas A and B are displaced by 16 centimeter and 9 centimeter. So let's take here displacement is D. So dA by dB here for gas A and B, 16 and 9 because they are telling A and B. So we can write here it is given here 16 by 9. Okay, and what they are asking here? They are asking here the radius ratio RA by RB. Okay, so this is the situation. Number of things are constant. Pressure, heat supplied, internal energy, dA by dB is given here, and RA by RB we have to calculate. So students, here we have to write here the thermodynamics law. How many laws are there? 3 laws are there. We are going to write here the first law of thermodynamics. So according to the first law of thermodynamics, you know very well here, delta Q equal to delta U plus W. Is it? So now what will happen that here? You can write here W equal to delta Q minus delta U. But the thing is what? Delta Q is constant, delta U is also constant. So constant minus constant. That is also the students. This is also constant because this individually they are constant. Okay. Work is given by force into displacement. Okay. Anyhow constant. Now you know pressure equal to force by area. So force equal to pressure into area here. Okay. Pressure into area into D constant. Is it? Now pressure. Pressure is anyhow, pressure is also anyhow constant. Okay, so pressure will go this side, constant by constant, again constant. So we can write here A into D is also constant. It is going like this. See, area means here pi r square, no? Cross sectional area into D constant. So here pi is also constant. That means r square into D, students. This is the constant. This is the basic thing we have to reach here. R square into D constant here. Okay. Now after that, if I write here, you can see very well here. See, RA square into dA is equal to for B, RB square into dV. So I can write here, see very well here, RA by RB whole square is equal to dB by dA. Is it? That means that this RA by RB will come what here? Square root of dB by dA. Is it? Now see backside here. dB by dA is 9 by 16 here. Just make it reverse. 9 by 16. So it will become here root 9 by 16 and it will become here 3 by 4 here. No? Kindly see very well here. No? So many constants are given. No? So why to do this much calculation? Even without that also we can do. So 3 by 4. The correct option is here. Option B is the answer here. Is it? Great. See all this we have done here. Now students, let's see this question. The question is what? From the oscillation C. Two identical point masses P and Q suspended from two separate massless springs of spring constants K1 and K2 respectively oscillates vertically. If their maximum speeds are the same, the ratio AQ by AP of the amplitude AQ for mass Q to the amplitude AP for mass P is how much here? Only the thing is given here, maximum speeds are same. Situation is what here? Like this here. Now it is oscillating here like this here. Now it is oscillating here. Okay, two identical point masses P and Q. Okay, this is K and like this is the general diagram. So remember that here, as they have given here the maximum speed is same. So remember that here V max for P will be equal to V max for Q. Is it? Because P and Q is given here. Now the maximum speed is given by A omega. So remember that here, A omega, that means AP into omega P is equal to AQ into omega Q. Okay, and remember that here one formula used to be there, K equal to M omega square. Okay, so from here omega is used to be how much here? Root K by M. How much here? root k by m here. Okay, root k by m. So I can write as root kp by m, and here also see the students here aq, and here root kq by m is here. Okay, now students, after that here identical masses, that means m and m is same only. Now after that, if I write here they are asking here aq by ap. Now they are asking here what here aq by ap. So what aq by ap will become here? It will become here root kp by kq. Can you see very well here, students? See, root kp by kq. Na? aq by ap will become here root kp by kq. Okay, so kp what is given here? For p means k1 and for q means k2. Is it? So we can write here, see, root k1 by k2. Is it? Root k1 by k2 is coming here. Option D here. Is it? I think so. Maximum to maximum calculation is all same only. Is it, students? Great. No? So now students, let's see here this question. The question is what? You see the question again, oscillations questions, little bit tricky questions. No, so see here. In an oscillating spring mass system, a spring is connected to a box filled with sand. As the box oscillates, sand leaks slowly out of the box. So when the sand will leak inside the box, mass of the sand will decrease, so that the average frequency omega t and average amplitude of the system changes with time t. Which one of the following option depicts all these things are there? Okay, so all these options and all is there here. Okay, so what will happen that here, students? Kindly see here, see here. I have drawn here like this here, is it? And here this spring is this, and here what is this? One box is this. Inside the box, what is this? Sand is there, and this sand is leaking. Now slowly this sand is leaking here. Okay, so first thing in the graph, they are talking about the graph of the omega and a. So as I have told you very well, k equal to m omega square. Is it? So you can write here omega equal to how much here? Root k by m. And you know very well the sand is keep on decreasing. No? The sand is keep on falling. So what will happen that here? The mass of the sand inside the box, it will keep on decrease. So what will happen that here? When m will decrease, omega will increase. So what we are getting that here? Omega will increase with the time. Omega will increase with the time. Okay. Now students, omega we have got here. Next one, if we talk about here, the amplitude, no? Amplitude graph is there. So amplitude is related to the energy, is it? So what will happen that here? If I talk about here, somewhere the mean position, for example, okay, somewhere is the mean position is this, no? Let's take for example the mean position is here. Now this is the mean position. What is this here, students? Here the mean position. So at the mean position, let's take here how much here? Elongation is the x here, na? Because with respect to this point, na, it is have to oscillate, is it? So what will happen that here at the mean position, students, here mass is mg, is it? And the elongation how much here? X, because you know at the mean position net force always used to be 0. So at the mean position what will be there? Kx equal to mg, or we can write here x equal to how much here, students, here? Mg by k. Okay, so now you see here what is happening that here when m is decreasing, x will also decrease. Now that means this block is keep on oscillating. See here, this side it will go, let's take for example plus a, and this side it will go minus a. But the thing is what? Because of the mass decrease, x will also keep on decrease. So this mean position, see here, this mean position slowly it will shift upward, like it is oscillating like this. Now mean position will slowly shift like this, and with respect to this is what? Again in position f, again it will oscillate. Okay, so mean position will shift upward here. Okay, so this x values keep on decreasing. You know the formula here, potential energy half kx square, just for the reference here, is it? So here also what is happening that here this x is decreasing, so you can see very well the potential energy, or we can tell energy of the system is decreasing. Okay, and you know very well that here energy is related to the amplitude. So as the energy will decrease, amplitude will also decrease. So a decrease with time, here. Okay, so see this first one, omega will increase with respect to time, a will decrease with respect to time. So kindly see which graph is this? Omega is increasing, a is decreasing. The correct option is here option B. Omega increasing, a is decreasing here. Is it, students? Great. Now let's see, this question is there, the last question here. The question is, a pipe open at both ends has a fundamental frequency f in air. The pipe is now dipped vertically in water drum to half its length. The fundamental frequency of the air column is now equal to how much here? Okay, so what is happening that here? First, this is the pipe, is this open organ pipe now, and let's take here this length is L. fundamental frequency, what will be there? The fundamental frequency in the situation used to be like this here. Okay, so in this situation, this F is given by V by 12. V by 12. Can you remember the formula here? This is which pipe? This is the open organ pipe. This is called the antinodal. This is also antinodal, and this is the node. Is it? Now after that, what is happening actually, students? This pipe, now this pipe is this, now this pipe is this, now this pipe. In this pipe, we are filling here the liquid. How much liquid is this? A half. Here, what is this? A liquid. Liquid is there here, okay, or water we can tell. Now water is given here. Now what will happen actually, students? Here it will become here, this one will become here L by 2, okay, and now it will behave as a closed organ pipe, and in case of closed organ pipe, it will be like this. Here nodes will form, and here antinodes will form here, okay. So now in this situation, the fundamental frequency used to be given here V by 4 L dash. Now this L dash is L by 2. So V by 4 L dash, how much here? L by 2, so it will become here V by 12. And what is V by 12? F, is it? So we can write here, students, here in this situation, this F dash will become here F. What will happen? This F dash will become here F. First open organ pipe, and then it will become here closed organ pipe. I hope so you have understood very well here. F dash is V by 12 and F dash will become here F. So students, I hope so this video of NCERT Part 2 you have understood very well. Keep studying, keep growing.